Now we are going to discuss about the layer of BMS. Each layer have their own function. Understanding the layers of the BMS can help you determine which level to check for a particular issue or problem at. The BMS comprises of three main levels. The first one is the field level. This level refers to sensors, instruments, valves, actuators, thermostat, and I/O modules. This level plays an important role in the building management system as the actions taken by the BMS is purely based on the inputs received from this level. Next is the automation level. This can be referred to as the brains of the building management system. It consists of compact or modular DDC controllers. The DDC processes the inputs from the field device and takes action to provide comfort to the building occupants and safety to the building equipment. These DDCs are programmable and can be connected to a handheld operator terminal that controls or monitors the field equipment at the field level without the requirement of any management system. Top of them is the management level. The management level provides an interactable user interface to the building operator. It displays all the information taken from the field level by the controllers in a graphical user interface format. The management level can either be a PC or an HMI, and it can also send data via SMS or email in case of any critical alarms. So those are the three BMS layers: field, automation, and management. To understand more about how BMS works, let's have an example. Let's use a sump pump from a field system unit. Assume that this system has just been built. A sump pump is a pump used to remove water that has accumulated in a water collecting sump basin, commonly found in the basement of homes or an industry. As shown in the image, at the bottom of the sump pit, we have a submersible pump and two float switches for high and low levels. In addition, a sump pit has a water pipeline and a discharge water pipeline. The main control panel, which can operate the sump pit in automatic or manual mode. Here is the sequence operation. A submersible pump will run to drain water into the sump pit if the level gets high, and submersible pump will stop when water level drops to a low level. At this point, operation of the sump pump relies on the main control panel, and there is no remote monitoring of alarms and level status. So in order to connect it to BMS, we need to add a controller or a data gathering panel known as DGP. So we've just added a data gathering panel. From the system main control panel, we will get contact points and connect it to the DGP. Contact points should be voltage free, also known as dry contacts. Now we will take the low and high level dry contact from the MCP, and it will be our low and high level status. The fact that it switches between 1 and 0 means that this will be a digital input. Anytime the DGP receives a high or low level status, a digital output is sent back to the MCP, giving the submersible pump a command to start or to stop. So from DGP, it will send a digital output to run or to stop the submersible pump. As we discussed earlier, The controller logic program will enable that sort of operation. And from the MCP, it will send another digital input signal to the DGP to indicate whether the submersible pump is running or not. All data exchanging by MCP and DGP will be sent to BMS workstation. This is how BMS works, which has the advantage of preventing operation from being halted by unattended alarms. As a result, the field system is remote and fully automated.